Hi, hello guys, welcome back to Technical YouTube channel. This is your Nikhilesh Sriram. It's been a long time I am presenting here, and now I came forward in this quarantine time to explain you the M1 subject for the diploma students. One of my followers asked me to explain me the M1 subject. If I open the M1 book, it being very tough. I says M1 is very easy subject. If you get only 3 chapters very thoroughly, then you will have definitely pass with 42 marks. First of all, I will explain those 3 chapters, and then I will go forward to the remaining chapters. Let's stop this nonsense and let's move into today's video. Watch our video till end very carefully. Today's our topic is partial fractions. Before going into the topic, you need to know about some keywords to move into partial fractions. First one is polynomial, rational fraction, proper fraction, improper fraction, and a partial fraction. I will explain a brief notes on polynomial, rational fraction, proper fraction, improper fraction, and partial fraction, and then we will move into the today's video. See, first keyword is polynomial. Listen carefully that these keywords are very important to know about partial fractions. So listen carefully today's video. What is a polynomial? An expression in the form of f of x that is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on plus an, where n is a positive number, positive integer, and a0, a1, a2, a3 and so on, a is a real number. Then the expression, the polynomial, is of the degree n terms with degree of n terms, and this polynomial is of x. This is a polynomial. Once again, what is a polynomial? A polynomial is an expression in the form of f of x is equal to a0 x power n plus a0 x power a1 x power n minus 1 plus a2 x power n minus 2 and so on, which ends with a plus an, where n is a positive integer and a0, a1, a2, a3, a4 and so on, which is all are real numbers. Then the given expression is a polynomial with a degree x. This is about the polynomial. Second keyword is rational fraction. What is a rational fraction? In an expression f of x and g of x are the f of x and g of x are two polynomials where g of x is not equal to 0, and an expression in the form of f of x by g of x is rational fraction. Example for rational fractions: x cube plus 1 by x square plus 2x plus 1 and x square plus 2 by x plus 1 plus x square. These are all the examples for rational fraction. Once again, what is a rational fraction? If f of x and g of x are two polynomials where the g of x is not equal to 0, and then an expression in the form of f of x by g of x is called a rational fraction. Next keyword, proper fraction. What is a proper fraction? In a rational fraction f of x by g of x, degree of f of x is less than the degree of g of x, then it is called a proper fraction. Let us take f of x by g of x in a rational fraction. F of x by g of x, degree of f of x is less than degree of g of x, then it is called a proper fraction. Example for a proper fraction is x plus 1 by x square. In this expression you can clearly observe that degree of the g of x is x, degree of x g of x is 2 and degree of f of x is 1. Here degree of f of x is less than the degree of g of x, so this is called a proper fraction. Next keyword, improper fraction. What is the improper fraction? The improper fraction is the reverse, exactly opposite of the proper fraction. Here let's the rational fraction f of x by g of x. In this, the f of x, degree of f of x is greater than or equal to degree of g of x, then it is called a improper fraction. Example for improper fractions: x cube plus 2x square plus 1 by x. This is a example for improper fraction. Here the degree of g of x is 1, degree of f of x is 2. Here degree of f of x is greater than the degree of g of x. And next another example, x cube minus 1 by x cube plus 1. Here degree of f of x is 3 and degree of g of x is 3. Degree of both f of x and g of x are equal, then it is called an improper fraction. Once again repeat the formula, definition of improper fraction. In a rational fraction f of x by g of x, the degree of f of x is greater than or equal to the degree of g of x, then it is called an improper fraction. Last keyword, partial fractions. What is a partial fraction? Resolving a given rational fraction into sum of two or more simpler fractions is called a partial fraction. Resolving a rational fraction into a partial fraction. For example, let us take an example for partial fraction. Let the rational fraction f of x by x plus a into x plus b. Resolving this rational fraction into the simpler fractions is called partial fraction, as a by x plus a plus b by x plus b. This is a partial fraction. The partial fraction chapter is very simpler. Now we are moving into the partial fractions, and if you go thoroughly through this chapter, you will have 3 marks in your hands. A short answer will come from this partial fractions chapter, and it is a very simpler chapter. And in this chapter only 2 models out there. There are 3 models, but for diploma there are only 2 models in the syllabus, case 1 and case 2. Now I will explain each sum in one sum in case 1 and one sum in case 2, and at the end I will give one sum from the 2 sums from the case 1 and 2 sums from the case 2 as your work, and I will reveal these answers tomorrow morning. After that, after revealing these answers from tomorrow morning and tomorrow afternoon, I will post another video of next chapter, that is matrices and determinants. Let's move into case 1 problem. Case 1. In case 1, g of x has non-repeated linear fractions. G of x contains non-repeated linear fractions. Example, f of x by x plus a into x plus b into x plus c, so on, plus x plus n. This is a form. In this, you can clearly observe one linear fraction is repeated only once. There is no any terms, square terms or squares or cubes. In this, only simpler linear functions are there in case 1. Case 1 is most important and case 2 is a little bit important. You have a chance asking you have only chance of asking two choices, case 1 or case 2. If you go thoroughly with these two cases, and then 3 marks will be in your hands. Now let us take an example problem for case 1 and let me explain this case. Example for partial fractions. Let us take our first sum as 1 by x minus 5 into x plus 7. Resolve this fraction into the partial fractions. Now the first step is to divide the whole fraction into two parts. Means 1 by x minus 5 into x plus 7 is equal to a by x minus 5 plus b by x plus 7. Let us consider this expression as expression number 1. And now do LCM for these two. If you do an LCM, then the expression is like as follows: 1 by x minus 5 into x plus 7 is equal to x plus 7a plus x minus 5b by x minus 5 into x plus 7. Then the denominator of the given fraction and denominator of the rational fraction is equal. Let's cancel these two. Then the expression we have is, the expression remaining is 1 is equal to a into x plus 7 plus b into x minus 5. Now we have to get the value of a and value of b. For that, let take x is equal to minus 7. Then the a value will become 0. Let us say substitute this x is equal to minus 7 in the whole expression. Then 1 is equal to a into minus 7 plus 7 plus b into minus 7 minus 5. Then you will get 1 is equal to 0 plus 0 minus 7 minus 7 plus minus 5 is equal to minus 12b. Then 1 is equal to minus 12b. We want to get the value of b. Now transfer this value into here. Then you will get b is equal to minus 1 by 12. Keep this b value in a box and keep this b value at a side, because we want to carry this b value to till the end of the sum. So keep this b value as a side. B is equal to minus 1 by 12. Now we want to find out the a value. Now put x is equal to 5 in the above expression. Then we will get 1 is equal to a into 5 plus 7 plus b into 5 minus 5. Then the remaining value is 1 is equal to 12a plus 0. Then we will get the answer a is equal to 1 by 12. Keep this a value in another box and keep this a value in the carrying with the b. Now we want to substitute the values of a and b in the expression number 1. Substitute the values of a and b in 1, then we will get 1 by x minus 5 into x plus 7 is equal to 1 by 12 by x minus 5 plus minus 1 by 12 by x plus 7. Now we can write the 1 by 12 as 1 by 12 into x minus 5 minus 1 by 12 into x plus 7. This is the first case problem. You see the problem, it's very simple here. Now let us move into the second case problem. Now case 2 problem. In case 2, the g of x term degree is more than 1, means it may be the square, it may be the cube, or it may be the 4. Now let us take an example for case 2 problem, and I can say that a simple step is differs from the case 1 problems to case 2 problems. Remaining everything is the same. So if you get the first transformation of the case 2 problem, then the remaining problem is same as the case 1 problems. Now let us see the example for case 2 problem. The example for case 2 problem is 1 by x square into x plus 2. Simple step we want to take while resolving this is, here we have s square, then we want to write a by x plus b by x square plus c by x plus 2. Simple. This is the only differ from writing the expression. Then keep this expression as expression number 1. Now the second step is same. We want to take the LCM of whole and write it in the single expression. Then we will get 1 by x square into x plus 2 is equal to, and if you don't know how to do LCM, see it. How to do LCM for this? Just take, we want to multiply with this form, x square, first take this, x square into x plus 2 into a by x, which will cancel, x and square will be cancelled. Then the remaining one is a x into x plus 2 plus same x square into x plus 2 into b by x square, then x square will be cancelled, b into x plus 2, then x square plus x square into x plus 2 into c by x plus 2, x plus 2 into x plus 2 will be cancelled, then c x square will be the remaining. The LCM is x square into x plus 2. Both the denominators on the LHS and RHS is equal, then we will cancel both the denominators. Then the remaining expression we have is 1 equal to a x into x plus 2 plus b into x plus 2 plus c x square. We got the final one? No, we got the simpler expression for the given rational fraction. Now we want to find the a, b, c and a, b and c values. Now we will find the a, b and c values. Now put x is equal to minus 2. Here b into x plus 2, if you put minus 2, the value of x will be 0. Now 1 is equal to a into minus 2 into minus 2 plus 2 plus b into minus 2 plus 2 plus c into minus 2 whole square. A value will become 0, b value will become 0 and c value is 4c. Now c is equal to 1 by 4. Keep this in a box and carry the c value into the till the end of the problem. So we will write the c value is here, c is equal to 1 by 4. We got the c value. Now we want to get the values of a and b. Now keep the x value as 0. Then c will be 0. Now 1 is equal to a into 0 plus 0 plus 2 plus b into 0 plus 2 plus c into 0 square. Now 1 is equal to a value will be 0 plus 2b plus c value will be 0. Now b is equal to 1 by 2. Keep this in another box and carry the b value till the end of the problem. So b is equal to 1 by 2. Now we want to find the a value. For finding the a value, see the process. To find the a value, we want to simplify the above equation. 1 is equal to ax into x, ax square plus ax square plus 2ax plus bx plus 2b plus cx square. Now take any similar one. You can equate the coefficients of x or x square. I will equate the coefficients of x square. Now equate the coefficients of x square. Means x square coefficients is ax and cx. Now we want to equate both the coefficients of x square with the 0. Means coefficients of x square is a and c. A plus c is equal to 0. We know the value of c. What is the value of c? Yes, value of c is 1 by 4. Then we will get the a plus 1 by 4 is equal to 0. Now transferring the 1 by 4 value to that side, we will get the a value. Then a is equal to minus 1 by 4. This is the value of a and we got the value of a. Keep this in another box and carry out the a value to the for next steps. A is equal to minus 1 by 4. Now we got the total 3 values. We got the c value, we got the b value, we got the a value. The next step is to substitute the a, b and c values in the equation number 1. Now substitute the a, b and c in equation 1. 1 by x square into x plus 2 is equal to minus 1 by 4x, b value 1 by 2, 1 by 2x square plus c into c means 1 by 4 into x plus 2. This is the resolving of partial fraction of case 2. You got both the case 1 and case 2. This is the process of the partial fractions. These are the only 2 cases we have in the partial fractions. Now the chapter partial fractions is completed. I will give you 4 sums, 2 sums from the case 1 and 2 sums from the case 2. I will not reveal now which one is case 1 and which one is case 2. I said how will be the case 1 and how will be the case 2. We have to find out the value, what is the case 1 and what is the case 2 and do the sum. Now I will reveal, I said before, I will reveal the answers of both those homework sums in the next video. Next video will be uploaded tomorrow morning at 9 a.m. or 9 to 10 or any time. So do the sums, and this is about the partial fractions. Now I will give the 4 sums as your work. That is sums. First sum 3x by x minus 2 into x plus 1. Second sum x minus 4 by x minus 2 into x minus 3. Third sum x by x plus 1 into x minus 2 whole square. And the fourth sum x square by x plus 2 whole square into x plus 1. These are the 4 sums I am giving to you as the work, and I will say the answers in my next video. And thanks for watching this video. This is your Nikhilesh Sriram, and if you have any doubts regarding this video or regarding the partial fractions, comment it down below. I will respond to your comments. And thanks for watching this video. A small request for everyone: please be in the homes in this quarantine time. Stay home and stay safe. Thanks for watching this video.